Hello, hello. Hello, everyone. We're going to get going here. If you're watching this after the fact, you might want to take a look at the description for time codes. Thanks to David for putting those in there. That's great because we're going to take a few minutes to get going, and then we're going to talk about a whole lot of different stuff. So know that those are there. All right, I'm going to pause these videos so it's not like watching a mirror back to me. And arrange my windows. So let me say some hellos. I'm getting a little glare off that. Maybe I should close that window. Hello, Unexpected Maker. Zarnlin, hello. Hello, Tammy. Hello, Keith the EE. Hello, Oats and Honey. Hello, Dexter Starbird. Hello, Minnesota Mentat. Hello, HamsLab. Congrats on the new job. Is the volume softer than usual for anyone? Can you hear me okay? I don't think I changed anything on my end. It's a bit quiet. I could probably turn it up. Oh, it's close to me. I can turn it up a little bit here. Hello! Hopefully I'm not blowing you out. Maybe I bumped it. Hello, Deshipu. Hello, Theodorus. Hello, Electronic Enigma Zone. Is that too loud? Hello, David. Hello, Paul. And hello, Beata. And YouTube. All right. I didn't get as much sleep as I normally get last night because I got up a little early. So we'll see how my brain does. But I guess a bit too loud. There, I turned it down a little bit. Hello, Cedar Grove. Hello, Dylan. Get used to no sleep. I tell myself that every night I don't sleep very well, that it's only a matter of time before I really don't sleep well. For a much better reason than not getting to bed soon enough, though. It's under my control right now, so I don't really have a good excuse. Hello, X Micron. Hello, Charles. Audio is perfect now. That's good. Okay, you know what? I'm getting a bad glare. I'm gonna put these down. Shade down. Like, I don't need to spend my whole time squinting any more than I'm already going to. My Discord chat is not scrolling. Let me see what I can do to that. Interact. All right, there we go. Ping the chat. Hello, Kinger North. Hello, Thomas. Looks like something came up. I think I got it. I think. One of those plants looks like a pothos, right? But what's the second one? My partner would know. she put those there. I'm not sure what they are. And I'm confusing the camera because it's bright in here and I've got a black shirt on, so, you know. Let's see how that goes. All right. Looks like it's scrolling. They look great and happy regardless. Yeah, she takes care of them. She's gotten a lot of plants around the house. We'll see how it goes when we have a kiddo running around too, or not running around. All right. I'm 6 minutes in and I haven't done housekeeping yet, so let's start there. So hello everyone. If you're new here, welcome. My name is Scott and I work on CircuitPython for Adafruit. If you don't know what those things are, CircuitPython is a version of Python designed for microcontrollers, which are little tiny, and I always have them on my desk. Here's a cutie pie. So here's a really tiny board here. And the microcontroller is actually on the back. And sorry for the I should maybe make it brighter. So there's a little chip here that has a full computer kind of all in one, which is super cool, called microcontrollers. They're really inexpensive, which makes them a great way to learn how to program and how to interact with the outside world. Minnesota Mentat says, excellent autofocus. Yeah, if you put it in the right spot and cover your face, it's not too bad. I can also put it on product showcase mode, and it's better there too. But yeah, it's still very happy with this camera. It was a good call to do it. If you don't know who Adafruit is, I work for them. They are an open source software and hardware company based out of New York City, and they kind of specialize in designing stuff for beginners and hobbyists and getting people to learn or teaching people how to use electronics to do things that they want to do. If you want to support me, you could do that by supporting Adafruit by going to the URL adafruit.com. And if you want to join our Discord server, which is the URL I almost told you, that's the middle box here. That's the Discord server. You can go to the URL adafru.it/discord to join us in the Discord there. And the great thing about Discord is that it's a chat room that lasts all week long. It's not just with a particular stream. So yeah, that's the Discord. That's chat. I'm there as Tan Newt. This is a deep dive. They happen every week. Only a few more weeks for me. They're normally Fridays at 2 p.m. Pacific. If you're also new here, I'm expecting my wife and I are expecting our first kid at the end of next month. So I'm only planning on streaming for a few more weeks. And then Foamy Guy, the plan is for Foamy Guy to start streaming in this slot on Adafruit. So we'll have a place here for folks as well. Or Foamy Guy will carry the deep dive torch, even if it's not called deep dive. These go for typically 2 hours or more, and questions are welcome. We've got tons of time to cover questions, so if you have questions, I'll try to answer them. The other folks in the chat will as well, and we'll hopefully get you your questions answered. So that's a deep dive. Next week is going to be on Friday as well. And then all the notes for these deep dives that David is so gracious and kind to take, they're available in a repo on GitHub, which is github.com/adafruit/deep-dive-notes. It's a great place to search. And if you want to find a particular topic that I've covered, you can kind of jump into the videos for that. So thanks to Patrick for curating all of those notes, and thank you to David DCD for making and maintaining or taking those notes. I really appreciate it. So if folks have questions, go ahead and drop those in the chat. This is a very informal stream, as those of you may know. The other thing I was thinking of, and there's a link to the note stocks repo. The other thing is, I forget what the other thing is. Let me take a pause and drink some water. So I thought I'd start with a mailbag because I did get an Adafruit order today. So I work remotely for them. I live in Seattle. They're in New York. And if I need to get stuff for the work that I'm doing, I make a free order off Adafruit and they ship me stuff. And I got one this morning. I'd almost forgotten about it. I have a habit of checking for packages and found it out back. So I was like, oh yeah, that's coming today. So I figured I'd start there. And then I want to kind of wrap up talking about ESP BLE stuff. I want to talk about kind of where I want to do some USB host stuff after that, hopefully. And then I'll wrap up with not talking about Adafruit stuff, but Patrick had requested an update on my Civic World, which is the broadband advocacy stuff that I've been doing. But first, before we get to Mailbag, we have a question. And sorry, David, for taking time code for Mailbag and then not actually getting there. Zarnlin asks says this is not an ESP32 question, but about your work with the Raspberry Pi Zero W2. I installed CircuitPython 7.1.1 on a Raspberry Pi W2 using multiple SD cards and hooked to multiple USB host controllers. My motherboard has 4 host controllers to choose from. I encountered 3 problems. When the CircuitPy drive is created, it's taking a long time and fails a lot. Lots of USB disconnects, and this results in lots of read-write errors. Change cables and Raspberry Pis. When you were working on this, did you encounter the same issues? First and foremost, don't use 7.1.1. 7.1.1 is pretty old for the Raspberry Pi stuff. So with the Raspberry Pi stuff, I recommend just using the absolute newest. Although Dan did just do a 7.2.0 Alpha 2 release, that's another place to start. But 7.1.1 is pretty old, so first try a newer version. I did see that it takes a while, and I think it takes a while because the very first time it has to format the file system, and I think the time that takes does scale a bit with how big your SD card is. Yeah, so try the newest. It is still flaky. It's not perfect, but I kind of ran up against the wall as to fixing all the bugs that I was finding. I couldn't figure them out. So it's not perfect. We still mark it as alpha. That's part of the reason. So, but yeah, try the newest. The 7.1 is pretty old. I think and this is something that we're kind of in this hole right now, is a lot of people do default to using the stable version, but there's a lot more subtlety to that because particularly new work goes into the newer stuff, and the newer stuff is therefore works better. So if the stable version if the stable version doesn't work, always try the newest ones. The only versions I ever use are the new ones. I don't really use the stable ones. And we recognize that it's been a while since we've done a stable release, so we're going to try to get a 7.2 out. We'll see about that. Dan was thinking that and did the alpha release, so that's a good start. I think the alpha release, we call it an alpha really because we don't have a good handle on what the major issues with it are. We haven't really kind of prioritized or talked about which issues are the ones that we want to fix before a stable release. I know we've had a lot of churn on the ESP side, so that's probably going to be the source of the bugs that we want to fix before a stable release. And that's all for the S3 and C3 support. Okay. Yeah, that's what Nerodoc's pointing out too. So hopefully I answered your question. It should work better. Yeah, Raspberry Pi should work better with newest, but it's not going to be as good as other stuff. It's not going to be as good as other ports, even then. Bad Abby says, I'm so used to using the newest version, it didn't occur to me to go back to the stable version when I2C didn't work on the S2. An unexpected maker says, gotta live on the bleeding edge. All right, let me switch to the overhead and I'll show you the stack of stuff that I've got here. Yeah. When is the IDF never updated? Before the S3 stuff, we didn't really update it. It sat for a while. Okay, overhead cats. Cat detour. Okay, so here's a stack of what I got. And let the camera focus. And it's upside down for you, and it's upside down for me, so that's right. So if I turn this, it looks right to me, and you can see it. So the first thing that I ordered, that's kind of gruesome. Tammy says the problem with living on the bleeding edge is that blood stains are hard to clean out of the carpet. Yeah, you gotta be pretty resilient to failures if you're on the bleeding edge. So first and foremost, I got this data cable, which is it's a USB-A socket, and then on the other end is just pin headers. And actually, I got a second one, so I'll show you a bit later that I've already got one of these already. But the reason this is useful is because trying to do USB hosts. So this is what you would plug like a USB keyboard into. So by having this on the other end, we can just plug it directly into a breakout board, which is what I'm doing, and we'll talk a little bit more later. Next thing I got is this is a multifunctional USB safety tester, which I found on Adafruit. And one of the interesting things is, yeah. One of the interesting things about USB hosts is that you've got to supply enough current to all of the devices that that are plugged into you. And so I thought it'd be handy to have, this is like an inline current thing. So this will be able to tell me like how much total current like all my devices are pulling, which I thought would just be handy. I do have like a power monitor thing, but I really don't care for that fine-grained of information. I just want an easy way of just seeing like what ballpark I'm in. And thank you, David. David is putting links to the stuff that I'm showing here, which will work for a little while, but Unexpected Maker caught a glimpse of some of the other stuff that I got here. So yeah, I got some Unexpected Maker new stuff here that I haven't even looked at, but the last thing that I got that's in the store is this CP2102. So this is just a USB to serial converter. And the reason that I have one of these already, but it took me a while to find it last time I needed it, and therefore I was like, I should probably have a second one. So I got a second one. They're really handy, especially for debugging the Raspberry Pi, where you have just like a UART that's spitting stuff out. So I just snagged a second one just to have. So that's the stuff that's in the store. And then I was going to get that USB-A thing because I was wanting to work on USB host. And Phil also mentioned that Unexpected Maker had sent some goodies to Adafruit before sending enough to sell, so that they would have a copy and I would have a copy. So thank you, Unexpected Maker. I did not purchase these, so take everything I say with a grain of salt, I guess. But what we've got here is a Feather S3, a Tiny S3, and a Pro S3. So I figured we'd just open these up and take a look at them. So let's take a look. So I've been doing a lot of S3 work, and this will dovetail nicely. I'll talk about the S3 work that I've been doing. And I have a demo that I think I want to try too. So here's a rundown of it. And that's right, Unexpected Maker doesn't tend to use... ooh, a desiccant packet. Right, so Unexpected Maker doesn't use modules, which is interesting. So these are with regular chips. And so I was going to say, oh, it's just this module. So what do we have here? We've got the dual core. So this is an ESP32S3 which is dual core 240 megahertz, runs CircuitPython, obviously. Wi-Fi BLE, 16 megs flash, 8 megs PS RAM, USB-C, and power protection, 2 regulators, RGB LED, ambient light sensor, VBAT and 5-volt sense pins, LiPo charging, LiPo connector, and optimized for low power, which is super neat. And it's one thing I'm excited about is that it's got the STEMMA QT port, which I do not, the Espressif dev boards do not have, so this will be nice for that. Make something unexpected. And then I guess I could do, let me just show it on this camera as well. Let's showcase the product, shall we, since we like these focuses. Is that better? Ooh. Maybe it's too close. It's all dark. Pretty dark in here. This camera's... The black shirt confuses it. So that's the Feather S3. It's Feather form factor. That's one of the 3 boards. And I think Unexpected Maker said that this is a new series from him. You can go to, yeah, ESP32S3.com. That's a good snag. So that's the Feather. Actually, let me leave the board itself out. I'm sure Unexpected Maker has shown them off next to each other before, but I'll do that too. I don't know if I actually have all of the form factors from Unexpected Maker. Oh, 2 STEMMA connectors, 1 for each regulator. So the second one has user-controlled power. Interesting. That's the first board I know of that has 2. Okay, so here's the tiny one. I'm not gonna, oh, it's 8 megs flash instead of 16, according to the breakout thing. Oh, and it's got a, so here's what it's got. So that's a tiny S3. And then one thing that's interesting is that it's also got a battery connector that you can solder on if you want, that would go here. So if you do want to battery power it, then you can do that. And that's 8 megs flash instead of 16, but it is 8 megs RAM as well. Hey Maiko, hey Johnny, hey Bruce, and hi Anessa. Toddbot says USB host in the title, oh my. We're not there yet. Not there yet, no. Okay, that's the tiny one. And then the Pro one. So this is, I just got these today, so I haven't actually set up any demos with them yet. Oh, and of course, I'm not on the right screen. So let me actually. Pin headers for size. So there's the Feather, tiny. Scooch my cables out of the way. First thing I see is a spammer. I'm ready to block people if need be. Mailbags are so funny. Yeah, thank you for commenting that overhead is off. Okay, so the last one that I got is this Pro S3, which I'm not actually particularly familiar with what makes a Pro a Pro. So let's take a look. So it's like skinnier than a Feather. It's equal pin headers along the side, and it's castellated, so you'd be able to put it down. There's nothing on the bottom. USB-C again, which is neat. There's a battery cable, but the battery cable has a bigger plug on one end than the other. So that's probably like a way to make it a bit smaller. Pretty standard pinout stuff. And then this is 16 megs of flash again. Microblade LiPo connector, castellated headers, and look at that, CircuitPython. Neat. So there's the 3 Unexpected Maker S3 boards. Thank you, Sion, for sending those to me. I have no excuse to not fix any bugs that come up about that. These might be the first boards that I have with 16 megs flash, so I assume I know you've tested them as well, but those are the sort of things that are actually quite handy for me for testing if I need to. Umut says, can I follow the stream for USB host on PiPico as well? Yes, that's what I want to talk about later. But I was going to talk about the USB BLE stuff too. Or the ESP BLE stuff first, before I get to the USB host on PiPico. The ubiquitous banana is needed. I don't have bananas, but I do have a box of cookies. And it's way bigger. Should I compare it to a cookie? These are kind of small cookies. I don't think they're a good reference. Zarnland says, I got some of the Citroen Nano RP2040 boards, which are really cool too. Pro has ESD protection as well. Kraton says, hello. Says, recently bought the Pico from Adafruit, loved the little thing, and then immediately regretted not seeing the RP2040 feather. Will definitely buy when I figure out what to do with the Picos. Yep, I feel ya. I'm definitely more of a feather person, which we'll see a little bit later. Umut, let me know if you can't watch the whole thing and we could skip ahead, but I thought I would show some of the BLE work off first. And perfect, this will be my, should I arrange these real nice so I can use them as my thumbnail? That could be one of my thumbnails. Cool, so those will go in my giant collection for, giant board collection. I split them up by like product. Generally, don't send me dev boards, but Unexpected Maker is always out in front with them. Too many good boards is a good problem to have. I only have so much space to store them all, though, I'll tell you that much. Okay, so next, where's Unexpected Maker? Unexpected Maker is in the Discord chat. Maybe not on YouTube. All right, like all my mailbags, I've successfully thrown everything on the floor. Okay, what else do I have for my demo? So I was kind of in the weeds of BLE last week, and I wanted to show off that it wasn't last week, it might have been the week before, or even the week before that. I had started converting the broadcast net bridge code over to CircuitPython native. And so what broadcast net is it was a very simple sensor data collection framework that just uses send you a new storage box as well. I've got storage boxes, it's fine. The main thing is like packaging. Like I had a ton of DigiKey stuff that was in bags and reels and stuff, and getting all of that stuff out of the packaging into smaller containers was like a huge difference. Okay, so I wanted to show this BLE BroadcastNet demo off. So BroadcastNet is BLE uses BLE advertising to transmit sensor data. It's unencrypted, so it's like not secure. So don't use it for anything sensitive. But if you're just emitting a temperature reading, like I don't think it needs to be secure. There's no like control aspect to it. It's simply just broadcasting data. So the way that it used to work is you'd use NRF52 boards and you would have them read a sensor and then broadcast out. And then there's a bridge that's involved. And the original bridge was a Raspberry Pi running Linux, which would do BLE scans. And then when it heard the advertisements that have sensor data, it would automatically then like write those to Adafruit IO feeds. That's really hard to maintain. Like a full Linux stack is hard to maintain, and it's kind of hard to know that it's working. So a few weeks ago, I don't remember exactly when, I was like, oh, you know, once we got BLE scanning working on the ESP32 S3, not the S2, but the S3, I was like, okay, great. Now we have enough working that we can actually do this bridge stuff in an ESP, which is way simpler. So I wrote that code. There's a pull request for it. Let me switch to the desktop here quickly. I think if we just look at, I have a new keyboard, which I should talk about as well. BLE BroadcastNet. Pull requests. Native bridge example. So here's a new thing. So Daniel says, can an iPhone work as a BLE key for our IoT devices? Key like authentication key. I think that's an interesting question. I don't know exactly what problem you're trying to solve. But generally, like if you need some sort of authentication, yeah, the keyboard sounds mechanical. It's definitely a mechanical keyboard. I've shown it off before, but I actually started using it the last couple days. But yeah, you should be able to use an iPhone to like get a security key onto a BLE device. But in this case, that's not what I'm doing. So this is the BroadcastNet bridge stuff. So it's in a PR if you want to follow along. I don't know if folks have actually done the BroadcastNet thing. It was kind of a pain with the Raspberry Pi, so it's a lot simpler now. So, for example, unlock your house. It tends to not be BLE. There's also a technology called NFC, which is usually used for like tap to pay. Is usually NFC, not BLE. I'm not a great I don't know a whole lot about that. By the sound, I would guess cherry blue. That is not true. These are they're browns. But we're getting ahead of ourselves. We're not talking keyboards right now. What do I want to pull up? Do I want to also pull up? Oh yeah, you can see all my keyboard stuff here. I think I could log into my feeds. So let's just view all my feeds. And you can see that there are some feeds here that were 22 and 23 hours ago. And actually, let me switch over to this. Let me say some hellos. Kraton says, any idea what's going on with Raspberry Pi and the stock shortage that seems to have created $50+ Pi Zero a thing? Adafruit doesn't really have a lot of insight into Raspberry Pi stock supply. It's kind of basically when we get them, we sell them. So I think that's better to ask of Raspberry Pi folks. Johnny's S3s are in the mail. And Mr. Align says, great seeing you. Hello. You did the BLE bridge with AIOBLE or similar or all async IO. It's not AIOBLE. It's not MicroPython stuff, and it's not async IO. But the BLE IO library is actually kind of asynchronous already. Let me just show you the details since I have it pulled up. So if you look in the code here, there's some helper functions, but the core scanning stuff is let me close this and make it bigger. So the core of this bridge is this start scan. And what start scan does is it returns an iterator. So it's asynchronous in the sense that like it will just yield you measurements as you go along. So it's not either of those things, but it is kind of async still. Like scanning and advertising still happens in the background. We have start calls and stop calls. And you can get data from that. So like start scan here will return a scan results object, which is an iterator, which will give you like individual things. But there's more to it because it's doing measurements. Anyway, it is asynchronous in the sense that you can like process things as you get things in. So let's start it up. And so many different things. So many different things. Okay, so let's plug in this one. Don't flip over on me. So let's connect to that serial by ID USB expressive. And I'll just hit reset so that we can see or I guess I Control-C it. Control-D is really slow on this, and it's weird. So this is what it'll tell you. It says like, oh, this is my IP. This is my bridge address. So it's like 7 CD. And then it knows what feeds were already created on Adafruit IO. So if we pull up Adafruit IO here, we can see that there's this group called 7CD. So this is a group of measurements we got from a particular sensor. And these haven't been seen for a while, but I've actually got them on my desk. So let me plug them in. So I've got this blue fruit here that is just reading the core temperature and broadcasting it out. So that's this FAB. So if I plug this in, should turn on, and I don't know, this USB, so now it's purple. I don't know if you could, I don't know how well that showed up. I've got my LED plastic if I need to put it on there. And it didn't auto refresh here, but if we refresh, we can see that now this has been less than a minute ago. So if we have temperature, you can see this is yesterday. And then this is the sample that it just broadcast out. So the NRF that I just showed is broadcasting, hey, here's my temperature. The ESP is listening for that, and then it's logging it to Adafruit IO. And this should, what I have this doing is that the NeoPixel blinks when it hears an advertisement and then reports it up to Adafruit IO. So it's not like super fast, but as it's doing that stuff, it still will be scanning. At least it should be. So there's one, and then I have, this is a ESP32S3 that if I find, I've got too much stuff on my desk. Where's another power plug? Come on. That's USB-C. have, this is C. Oh, here we go. Here's a B. Okay, so I'm plugging in this one, and let me, I don't know why this USB cable insists on being flipped over, but I have a solution. So if you don't know, another thing that Adafruit carries is called this, it's like LED plastic. So it's like super, like pretty opaque, and it's great for NeoPixels on camera or LEDs on camera. So I'm gonna flip it over, and then I'm just gonna put this on it. And hopefully it'll hold it down. So you can't see the board, but you should be able to see the blinks. Yeah, see, so there's a purple. And so that was hearing a report from this purple guy, from the NRF. And I'll just put my hands on it. And it's running code right now that only as temperatures change will it actually broadcast. It's meant to like save power. So what I'm doing here is I'm holding it in my hand to try to heat it up. So you can see it's broadcasting a lot. And then let me plug in this ESP that I just showed, and it just sends the temperature value 40 over and over and over again. So hopefully we'll see a different color blink here, if that code's working. Which maybe I was using it for something some other day. I don't know. Doesn't look like it's working. Maybe I loaded something else on it. Or I broke it. It blinked okay. And it showed up. Oh, I missed it. So this is the output of the bridge. So it will tell you what it logged. Yeah, there's a green blink. So correct. So Unexpected Maker says, sorry I was at the pick in place. So the background BLE scans are non-blocking, so CircuitPython user code is not interrupted. Correct. And the results of the scan are buffered. So there's a primitive first filter pass based on the contents of the advertisement, and if it passes that filter, then it will be queued so that you can go through it later. You know, a lot of what CircuitPython native code is all about is about making it so that you don't have to worry about timing in Python. It does all of the buffering for you, which has the converse effect that it's not particularly good for doing timing sensitive stuff. Hi Bjarki. Says, I just finished making a home VPN. Good work. Okay, the one thing I wanted to point out, I thought this was a really interesting use, so I just wanted to call this out. What you see here is that we're kind of blinking two different colors, and this is what I wanted to be able to have different colors to know which sensor I was hearing. And one thing I had a problem with the Raspberry Pi version of this is I couldn't tell whether it was working or anything was going on without pulling it up on my computer, the charts on my computer. So the nice thing here is that because I have things broadcasting at a semi-regular interval, it kind of tells me that things are still working by the blinks. And I thought it would be cool if automatically it would blink a different color per sensor, so you could kind of get an idea of which sensors it was working with. So I didn't hard code these colors. I thought of this neat trick that I thought I should share with you all. So here you can see that we're starting to get more stuff into our feed here. I don't know if there's a way to tell it. I found this hilarious because it live loads. You can actually get more than 100% loaded. It says 129% loaded. because it started a particular amount and then it adds the new ones to go over 100%, which I thought was kind of cool. So the trick I did for picking the color I thought was really clever. And clever is not always a good thing, but here's what I did. So CircuitPython now has Rainbow IO as a native module. And typically this is used for LED animations where you see like the color swirl, like the classic color swirl. And so we have Rainbow IO and then .colorwheel. And what you can give it is you can give it just a number and it will produce a color for you. And it changes it repeats kind of every 256 values. So what I'm doing is I'm just taking the BLE sensor address, which is what reversed address is, and then I'm just adding them all up and then passing that number into color wheel to get a color, and then I'm setting the status neopixel to that. Yeah, making sure it's an int. I don't actually make sure it's an int. I don't know if you can fully appreciate how cool this idea is, but the thing I did first was actually I took like it's 6 bytes, and I took like certain bits out of those 6 bytes and I just like smushed them together to get an RGB value. But the problem is that it was really hard to distinguish the two values because inevitably 3 components end up being like kind of all the same. So it's what the neopixel ends up looking like is more like a color white, like different shades of white, because you're always getting 3 of the components. And so this is a really neat way using color wheel, which is built in, so it's not a new library. So given just a value that is hopefully unique but may not be, you can get a color that's like reasonably easy to distinguish from other colors. So I was pretty happy with how that worked. And because these addresses are stable, the colors are the same like every time you open it up, because the sum will actually be the same thing. Of course, if you don't keep a consistent address, it'll still work. Their colors will just change. So I thought that was a pretty interesting, like color wheel is so commonly used just for animations that I thought this was a really neat use of it as a way of like encoding like unique devices talking to a central thing. Yeah, so this is the native bridge is now it's not in the library yet, but it's a pull request. So if BroadcastNet is something interesting to you, there's a Learn Guide for it as well that John Park did, but it's, like I said, it's pretty complicated given that you have to use a Raspberry Pi. Aza's built to code says neat visual representation of a hash code. Yeah. And Dinkelberg just sent a rainbow, which is perfect. Yeah, let me see if I can. I don't know how often it's been blinking here, but you're watching it, not me. Gamma Games says, color wheel is handy. I used it for time.monotonic nanoseconds to get a nice rainbow loop when processing audio. There you go. And that's what Toddbot was talking about too. Toddbot was using it with time nanoseconds, or time monotonic, not even the nanosecond version. There was a green one. So yeah, I was like, what I'm trying to do is wrap up all this BLE stuff so that I can move on, because it's been kind of a slog. I don't know what happened with this. Not getting purple ones in. That's the other problem. But at least you know, you could see it did just get one actually. Yeah, so I just wanted to show that off. This is the guide for it, this BLE sensor nodes thing. And like, it's really complicated. Like if you look at these instructions to get the Pi bridge going, like, so the ESP32 S3 is the first CircuitPython native board that has both BLE and Wi-Fi. And I think this is one of the reasons I was really excited about it. Before then, we had to use a Raspberry Pi, which is not simple, which is what these instructions are. So, making an I'm Alive LED. That's a great idea. So yeah, hopefully we'll update this guide with a simpler bridge once it's committed and once we have an S3 in the shop. I guess we have the Espressif dev boards in there, but we'll see. So that's a piece of it. Another piece of it is that I did get packet buffer working. So if you look at Adafruit BLE, I have a pull request for packet buffer test examples. And let me talk about this a little bit. So here's the client. So we have, like I talked about earlier, CircuitPython really tries to be a, let me switch to camera. CircuitPython really wants to insulate your Python code from having to be time sensitive. And with BLE, we provide kind of two primitives to do that. Well, three. The first one is regular characteristics, where you can just get whatever value was most recently set. So that's kind of like a buffer of 1, where you're always just getting the latest value. But then there's tricks that people have played with BLE, where they actually send a stream of values, and you want to kind of buffer the whole stream. Think of it a lot like a UART. And so that is we have a characteristic buffer, which kind of like smushes all the characters it gets together and just treats it like a UART. And then lastly, we have packet buffer, which does the same thing as characteristic buffer, except it keeps the boundaries of the packets in case like packets are defined as like different positions matter differently. So packet buffer is useful for that. Okay, Unexpected Baker has a couple questions. Do you have Wi-Fi always on and connected to the router? And do you know your current use when you're scanning and sending with Wi-Fi? I'm not doing anything fancy with the Wi-Fi, so it is always connected, and I don't know the current. I don't really care because I'm assuming that this bridge is powered. I wouldn't necessarily assume that about the nodes that are advertising, but like I'm coming from a world where it was a Raspberry Pi, so I'm expecting that the bridge is powered. So no, I haven't looked at it. I'm not doing any sort of code changes to reduce power use. Heartbeat/watchdog indicators are always a good idea for almost every project. I'm a fan of tacking a piezo under the NPU board too. Yeah, so packet buffer is actually really handy for scenarios where you're like potentially getting a stream of packets that are like variable size buffers, or you just need to make sure that you kind of keep them all together. So packet buffer, I think, is used in BLE MIDI. I think is one thing that packet buffer is used for. I think that's the primary reason I added it. So I wanted to add client support for that. So let's just quickly go over the code here. We can see there's an outer while true loop. We've got this buffer. So first we say, oh, if we're connected to anything and any of the connections has a packet buffer service in the connection, then we know we're connected to something that can do what we want. We look through the connections again and find the one, if it doesn't have packet buffer, we don't care. And then we print echo, and then we find the service. So this is how you get, with BLE.io, this is how you get a service object to be a client of it. So you could say, oh, connection, do this like dictionary style thing. It's a little funny that the key is actually the class itself, but it's actually a really handy trick because we actually use this to like instantiate it, I think. So that gives us, PB is now a packet buffer service object that's related to the service on the other end of the connection. And we can just call .write with a write buffer. So this is sending the 4 characters echo all together as one. And then we read into a buffer that packet back and print it off. And we use read into so that we minimize our memory allocations. And so we have to give you back how much we actually read into the buffer, which is why we're checking it here. And then also, this is actually a memory allocation here. I did all that work only to print it out again, but you don't always need to print out just the buffer. So that's kind of half of what this client example does. So if you're connected, that's what you do, that's how you connect to a service. And then the other half is if you're not connected, what you do is you do a scan. So this is like very similar to what we did before. But I should have said that what we do is you provide the advertisement type that you care about. And that means that the BLE inner workings will only buffer advertisements that match that type of advertisement, which is a great way to just ignore a bunch of stuff. Because there's a lot of BLE advertising that's happening all around you that if you've never looked at it, it's kind of wild. Maybe I should just show you. So I think I've covered this before ages ago, but let me just emphasize that fact. So here's my phone. Let me switch to overhead. And maybe I should use CircuitPython for this anyway. But here's my phone, and this is the NRF app, and I just pulled up to refresh. So it's scanning right now. And you can just see, so UDM is like my Wi-Fi router. Eve Energy is like a power monitor thing. I don't own a Samsung TV, but somebody's Samsung TV's broadcasting out. There's Eve Energy. This LYWS thing is like this temperature sensor here. There's something Google. There's another Eve Energy, my iPad, like another Samsung monitor, another sensor, Hatch Baby Grow, which is like my sound, my headphones, which are sitting here, my Apple TV, like BLE advertising a CircuitPython device. So this is interesting. This is the broadcast net advertisements that my phone is picking up as well. So they have manufacturer data that encode all of the temperature stuff. So you can actually have multiple things listening for it. So point being, there's a lot of stuff that's going on in BLE scanning world. And so having that first pass that start scan does for you is really handy. So you don't have to buffer a whole bunch of stuff that you're just going to ignore. You can do a first pass, which is great. So that's what this is. And then again, you skip all the advertisements. So this is getting more detailed. So if the services that are provided are not the ones we care about, we continue. Otherwise, we try to connect to the advertisement or to the thing that advertised that. Then we say connected and we go around the loop. We stop scanning and then go around the loop. So that's the client code. I thought I would talk about, I don't know if I've ever covered this, and I should write a guide for it, but I don't really write guides very well, so I thought I'd cover it here. And the question is how do you make a custom BLE service? And it's really kind of weird how we do it in BLE.io, but I like it. And this kind of made me revisit it again. So first and foremost, what you tend to do is you have a kind of base UUID. So UUIDs are unique identifiers that are associated with a service, a characteristic, and descriptors for it. What I like to do is I like to use ADAF as a prefix, and then these 2 zeros here are where you put a unique number, and then I encoded the rest that says packet buffer. So that's my unique ID. They say you should actually use random numbers, but I kind of enjoy making it words. So first I have this packet buffer UUID that just takes the 16 bits that are going to be unique, and the rest are the shared across everything. So that's kind of your framework for unique IDs. And then packet buffer is weird in the sense that you can't just read and write it directly. You actually want like this object to fit in here. So a packet buffer characteristic is a complex characteristic, which means that when it's created, you learn stuff about it, but then it gets bound to a particular service, kind of the first time you access it, or at some point. So it kind of gets replaced. And what do I mean by that? So here's the service itself, and this is why this API is weird, but I like it. So the idea is that you have one object that can work in both ways as both a client and a server. And those details between those two things are like, we try to hide them all from you. So first we give it a unique ID, which is just by setting this top level property or attribute of UUID. So we instantiate our packet buffer UUID with the 0, 1, 16 bits in the middle. And then we're going to make a second entry that's packets, which is a packet buffer characteristic. And then we give it the 0101 UUID. And then so these constructors actually get called when the class itself is created, which is kind of weird. So this is using a thing in Python called data descriptors. And it's a weird way of, if you've ever used properties to say like, at property, call this function for this thing, it's a way of factoring out those kind of functions further. And in reality, that's what property actually does as well. So when the class is created, these constructors are made, and then these things are set. And then what service will do is when you create an instance of it, so that's like the dunder init, it will actually, so complex characteristics like packets, the object that's saved at packets is actually replaced. This packet buffer characteristic is replaced by the packet buffer object itself, which then you can do self.packets read into and write, which is the API for packet buffer. So I know that's complicated. I don't know if anybody's following along and has questions. But the goal with this kind of weird API is that you declare kind of what your service is, and then it's like pretty straightforward to use it. Simpler cases are where like if you would just say like packets equals a string characteristic, you'd be able to then just say like packets equals string or like print packets, and that would tell you what the string was at the time. But this is a complex characteristic, which means it gets replaced by a separate object. And then I guess I should, for completeness, so this is the server side. So you say, oh, I want the radio, and oh, I want to provide this service to everybody who connects to me, and I want to advertise that. So I'm saying I'm going to advertise that I have this packet buffer service. I'm storing a buffer array. So I start advertising, and then I just wait until I'm connected, and connections will just stop advertisements. And so by the time we pass here, we know that we're connected. And what we do is we just read the next packet, and then if it's greater than 0, we create the new packet and write it back, print it out and write it back. And we just keep doing that while we're connected. So that's the server side of packet buffer service. So I thought this was kind of a good like self-contained example, but it's not it's more complicated than a simple example would be because of the complex characteristic. Okay, so that's BLE. And I can clearly see that people are all very enthused by that. And this is still going, which is cool. Is that this for characteristics? So this complex characteristic is a thing that is done by the BLE library. They're all characteristics under the hood. So if we look at BLE and we go Adafruit BLE characteristics and init, we have this Python world characteristic. which kind of wraps around the underscore BLEIO characteristic. You can see it actually stores one. I was with you up until right after you said hi, I'm Scott. Yeah. It's a deep dive for a reason. You don't have to feel bad for not being able to follow along. Yeah, so this is the BLEIO version. It does fancy binding stuff that generally just works. The data descriptor part is this getter. So if it's a basic characteristic like this would be, what it does is it says like, oh, let me get the value with the given service, and then it can get it from the underlying thing. So it just does, like the characteristics API you link to allows you to just do this dot value and the dot value right. But complex characteristic does the binding a different way. So the getter says like, if service is none, then we return ourselves. Otherwise, we call bind on our subclass, and then we set the attribute of the service given the field name back to that thing. It's a lot of Python magic, I will give you that, but you don't necessarily need to know how it works to use it. And it works pretty well, I think. Like the code is really clean, being able to just say like, all right, now I want packet buffer. So then you can do things like we have struct characteristic where you can just say like, here's the struct format, and it packs and unpacks the value reads by overriding get and set here. And then if you look here, we have like basic int ones as well. So we have int characteristic, we've got int 8, uint8, int 16s. So you can make it really concise to declare things. So if you actually look in services and then standard, this device info is much more basic, where you can see the device info service is just a bunch of fixed strings. So on this service, you can just say model number equals or read model number, and it just works, which is kind of wild. I think it's kind of wild. Zarnlund says, I download the two files from the S3, the UF2 and the bin. I need to write the bin first to the S3 when it should boot with a bootloader directory where I drop the UF2 file in. Is that correct? I'm not sure. I'm not sure if the S3 has UF2s on it. I've been loading it using the make file. I bet that unexpected makers boards have UF2 on them already. The way to get in that is if you hit reset and then hit boot. So if you hit reset and it's purple for a little while, that's when the bootloader is waiting for you to get into it. Bad Abby says, is there an example of this being used? Yes, maybe. There are examples in this BLE library. There's examples. If you just look in examples here, like if you want to see how to use device info service, there's this. So, and this actually does both sides of device info service. I just added this to be fair, because somebody was asking about it. So you could say, here's my info, construct it, tell it what my manufacturer name is and model number. And then once you're connected, so anything can connect to you here. Once you're connected, you can get the other device's device info service and print out its manufacturer and model number. Somebody was asking about being able to determine what's connected on the other end of Thomas was asking for this, where like, I want to know whether I'm connected to an iPhone or an iPad, for example. This example the model number is different. So it will tell you what you're connected to. I'm looking for where to learn more. What are some other Python search words? So the term for the complicated get dunder get, dunder set is called a data descriptor. It is definitely the kind of weird corner of Python. This is probably what you want to look at, I think. Wrong. I can't decide where I want control versus delete, which has caused some problems for me. So there's that. Yeah, so, and then like all of our BLE libraries are built on top of this fancy stuff. So yeah, I would look at the BLE libraries. I don't think that there's been enough people, like a lot of people haven't kind of built on top of it because I haven't done a great job actually documenting it. Kevin, is there a way to make the Raspberry Pi Zero run CircuitPython the same way the Pico does? I'm trying to use USB HID on the Zero, but it won't work and Pico runs too slow. You're in luck. It's not super reliable, so that's the caveat. But if you go to learn.com, learn.adafruit.com and do Raspberry Pi, not this. This involves Linux. But I wrote a guide. How do I find it? I know I said no OS. There we go. CircuitPython on Raspberry Pi, no OS. We do build regular CircuitPython for proper Raspberry Pis. It's early. It may not work, but if it does work, the HID stuff should work as well. And the Pi Zero or the 02 are probably the best platforms for that. Oh, complex characteristics is a BLE library thing. It is not a BLE spec thing. It's like something I came up with. Yes, Zarlin, if you want the UF2 bootloader, you do want the USB connector. But I'm not sure whether the board that you have has it installed already, because it's not baked in. But yeah, complex characteristics is a concept for the BLE library only that I came up with. All right, well, we have lots of topics today. I wanted to get to the BLE. Do I want to talk USB host? Let's talk about USB host. Let's do that first. So let me zoom the overhead out and show you the setup that I've got here. I'm going to unplug this thing that insists on being there. So let's go to the overhead. Or wait, let's go here first. So do I have it? This is all my keyboard stuff. Oh, there it is. This is what I want. Yeah, so there's this really cool thing that somebody did. They got the Raspberry Pi Pico doing USB host using PIO. So there's been a few examples of doing USB host from the USB peripheral on the Raspberry Pi itself. But this person managed to get it working without using the USB peripheral, which the reason that's so cool is that you can, Tim says tab groups for the win, 100%. I guess I do use tab groups, but I turned off, this is kind of like a small screen for me. So I turned off the tab hierarchy thing. Yeah, tab groups might be something separate. Anyway, so this person, Sekigon Gonok, not sure that's right, did this really cool thing. So let me just play this quick video. There's no audio, so you're not missing that. So this is a Raspberry Pi Pico that's acting as a keyboard. And then they're plugging in another one of the same thing. And so the first one is acting as a USB host for the second one. And then they add a third one, and the third one acts as a USB host for the third one. Triple split keyboard. And then they put a trackball on it with this receiver here. So like, this is really neat. This is really cool. It's a USB host as a second USB kind of peripheral for the Raspberry Pi. And I should say thank you to AT Makers for pointing this out. I think we had seen it before that, but it's always good to hear, like, see if multiple people like recognize cool stuff like this. So, so this is really neat. You know, a lot of what CircuitPython does is all about USB. And so being able to be a USB host would be really cool. We talked about this a little bit prior when we were talking about Broadcom, like the Raspberry Pi, and being able to do USB hosts so that we could kind of take keyboard input directly into CircuitPython and have a standalone experience. So I've been thinking about how to do that. Been thinking a lot about keyboards, which we'll talk about. We can talk about too. But USB host kind of dovetails right into that, figuring it out. So I just wanted, let me just show, and here I have like a key puller as that I'm fidgeting with. I got this working. So that was my goal kind of this week. Not this week, today. My goal today before next week was to start. I don't like to get into huge projects on Fridays, but I can like do pre-work. So here's what I've got. And go to the overhead. Oh, and you can't buy USB host ICs at the moment. Interesting. I'm not too aware of what you can or can't buy. Overhead. I'm not used to doing overhead. Let me hit this button to get it focused, hopefully. Did that focus better? Oh wow, look at the color change because of the window. Okay, so here's what I've got. I've got a Feather RP2040. This is the copy of this is the thing I showed earlier that has a USB-A on one side. And then I've got it plugged just directly into the Feather here, where I'm taking red as power, so that's power from the USB, so that's 5 volts. I've got ground, and then white and green are plus and minus, which I don't remember which is which, so don't take my word for it. Or don't, like, check your work before you do that. So I've got this thing. Let me switch to desktop overhead and see if I've got, yep, I've got, this is where I restarted, so everything's been messed up. Dev serial by ID, and we want the Raspberry Pi Pico because it doesn't know it's a Feather, I guess. I don't have a Pico on my desk, so it's certainly not that. And then what I've got here, and the reason that I'm having trouble finding everything, is I've got just oh, you can't see. I've got a mouse. I've got this old Microsoft mouse. It's still optical. It's not super, super old. And what I'm going to do is I'm just going to take that and I'm going to plug it in. And we can see here that we got a root 0 connected, device 0. There were some failures, but then some control stuff worked. It got a report descriptor. And I think if yeah, so I'm clicking the button and we can see the reports. I can do the scroll wheel backwards and forwards or whatever. The other button, this button, and then I can actually move the mouse as well. So this is the example for that repo of just dumping the USB information, which is very, very cool. I did make the mistake, it might be a mistake, of I have a USB logic analyzer, this Beagle 480, and it can keep track of what's going on through it. And there was a lot of errors, unfortunately. I think it might be because this demo is doing so much printing. That might be the problem. So one thing that's interesting to Lady Ada is having the ability for us to do this from CircuitPython. It's super early and I make no promises, but it could be really cool. I've thought about how you take keyboard input and what you do. Could that be used as a USB diagnostic tool? I don't know. I don't know if you want it to be a USB diagnostic tool because you're like reading all the data and passing it back through. Data plus and minus wires go to the UART TX RX pins or any pins. So this is using PIO. So the constraint here is that the plus and minus have to be next to each other. So in order, and that's a PIO constraint where PIO can address like pins next to each other. It's not related to UART TX and RX, so it doesn't matter for UART. It only matters for the PIO. So they have to be next to each other. So for example, here I have them on 11 and 12, and there's just settings in the code that you can change that for. But yeah, they have to be next to each other, but besides that, there's not really a constraint. And it takes like two PIOs and 3 state machines, I think, where there's like, yeah, I haven't dug super into it yet. That's going to be what next week's about. Really learning host. And so my first step that I want to do for this is I want to get this code running in TinyUSB. So TinyUSB does have a host stack that I think it would be great to make even more awesome. So this code here kind of does it itself, but I want to be able to do, I want to first get the TinyUSB host examples working in this way, which I think would be really neat. This is pretty timing sensitive. So this demo is actually using the second core of the Raspberry Pi, of the RP2040 to do all of the timing sensitive stuff. David asks, just wondering, but why not use the RP2040 USB host hardware? Because we want to still use the regular USB hardware for device. That's why we actually do want to be able to do host and device at the same time. This person who wrote this code is very much into mechanical keyboards, and they're using it as a way to do like remapping of existing devices. So you can take a stock keyboard and decide that your keys are going to mean something else to the computer, which is one cool case. The other case, so if you want to follow along, let me advertise this. We've got a couple new issues on the CircuitPython repo. You could go issues and then Support USB host on the RP2. So issue 5986. So if you want to follow along, this is where the updates will go. You can see the AT Makers Bill pointed out this stuff. And then AT Makers is pointing out that we have a number of conversion projects that take old equipment and convert them to current standards. One example of this is also being able to do like, remapping keys is one, but potentially, this is a bad example because RP2040 doesn't have Bluetooth, but you could imagine a world where you want USB host and then to switch to Bluetooth so that you can connect to like an iPad or an iPhone. But yeah, I think that but yeah, for right now, they're doing like USB host in Arduino out to UART that goes to a trinket that's running CircuitPython or something. So yeah, it's something that's really interesting, and it dovetails nicely because I would like to learn a lot more about USB host for the Raspberry Pi, the proper Raspberry Pi, because I really still would love to have the keyboard on the RP or on the Pi 400 working. So I was like starting to read the XHCI spec and trying to figure out kind of what my game plan here is. First step, I think, is to get TinyUSB running this code. Perfect topic. I've been experimenting with the easy dock, but I can't make the switch. You can't make the switch? Why not? So let me show you what I've switched to. Let's dovetail into this other topic. So one thing that keyboards actually do a lot of is converting from one thing to another. So you may have seen that I've got this colemake website up, and I've got this CMK configurator. So this allows you to change what happens when you press a key. So this is my current setup. I don't know the best way to show you. So if I just go to the overhead, I don't think I have range. Let me just tilt it up and hopefully. So this is my setup here. You're looking like sideways. Let me move my phone out in case something comes up. Kraton says, still learning USB comms using TinyUSB. Question. In order to have a Pico or ESP32 communicated with a user space program, is serial comm the only option? Serial comm is a good option. Serial communications is a good option because you really want to think about what the host has drivers for. And yeah, it's really important what the host has drivers for, and all of the major operating systems have CDC support, which is serial support by default. So that's what I recommend. Kevin says, so I followed the guide and have CircuitPython installed, no OS on the Raspberry Pi 02, but it doesn't seem to work. Yeah, it's flaky, sorry. The Discord's a great place to join. I'm almost done for the week, but maybe next week I can, maybe I'll circle back and try to fix some stuff. Make sure that you have HDMI plugged in, because HDMI will tell you a little bit more information about how far it's getting. Somebody else got it hung up where it was just on the like rainbow screen. And then you can do debug builds and get UART output that might tell you more too. Umut says, what I'm really interested is making a MIDI USB host. I hope it's not so different than what we're doing here. So TinyUSB has MIDI host support already, I think. Which is why I want to like port it to TinyUSB. So USB really is, and TinyUSB is great because there's like a very relatively small API like at the bottom that's just like about sending packets to and from, and then on top of that is a matter of like different classes and stuff, and that's all shared usually. Nico says, "Hi Scott, would you have an ETA of USB 2.0 host support for high-speed devices in TinyUSB for the original Pi Zero? Only the Teensy 4 chip has both supported for now." I don't do ETAs. The best I can do is for ETAs is just a matter of if somebody's working on it or not. You never know how long something's going to take until you're done with it. So I don't do ETAs. Nobody is working on host support for the BCM 2835. It's probably easy. It might work. It might work. I think we might have support in TinyUSB for the USB peripheral that is currently being used in the 2835. What I'm interested in is host support over the XHCI chip on the Pi 4 and the Pi 400, which is different. Only the Teensy 4 has support for now. Has both supported for now. Yeah. And in CircuitPython, we don't do any host stuff yet. Flashing rainbow on HDMI, what does that mean? Flashing is interesting, but the rainbow thing, it's CircuitPython getting stuck, and I'm not sure why it's getting stuck. I saw this with somebody else. I haven't touched it for a few weeks, which is kind of unfortunate, but I'm just not working on it right now, so I can't really help you. I don't have a lot more to say. I would get a USB serial converter to see if there's anything coming out of the UART, but... Okay, thank you. Welcome. Yeah, and join the Discord. There's lots more awesome, helpful people on the Discord, so it's... I'll just type it in. So, let me show you how I type. Okay, so here's what I've got. Yes, TinyUSB has USB host support for HID, and there's a PR for MIDI, but that's it. I think it has CDC as well. Okay, so here's my setup here. So I've got this trackball. This is a Ploopy trackball. It's open source, which is pretty neat. But it's a 8-bit micro. It's not a 32-bit, unfortunately. And then what you can't see here is this is a touch sensor that I have. It's just a little off camera. This is a cutie pie, and if I put my hand on my trackball, you can see the light turns red. So that's it detecting that my hand is on my trackball. That goes into here. So this, which is what is the keyboard, can detect when and pretend that I've pressed a button when my hand's on my trackball. So if I want to click a mouse button, I can put my hand on my trackball, and then on my right hand, I actually have keys. So I don't know. I don't know what's more useful. Like, this is my left mouse button, and like I've got a setup here, and I guess let me do desktop with overhead. If we look at the QMK setup, I've got layer 4 here. Oh, this is not mine. This is not my setup. So one thing you could do is you could load it. So let me upload the most recent one. I've been iterating. I have 12 iterations. So this is a cool editor. And this is my 4th layer. So this is the layer that's active. I'm not actually a lefty. I'm right-handed, but I had pain in my right hand from mousing so much that I actually switched to my left hand. So I'm a left-handed mouser now. So this is what the keyboard's set up when my hand's on my trackball. Page up, page down, which I was doing a scroll wheel, and I might actually switch back to scroll wheel. Page up, page down is real nice in most cases, but there are a few cases that don't respond to it, which is annoying. And then 3 mouse buttons. So I can do that all from my right hand here. And then if I lift my hand up, and let me click here first, or am I running KMK or QMK? I'm running neither. I have my own code because I am like that. One thing I did want is, and KMK can't do this as far as I know, is like I wanted to be able to iterate with this nice editor. So layer 3 doesn't do anything. But if I do my pinky here, it goes into arrow key mode, which is nice. And generally then I just do colemake. So this looks like QWERTY, but my computer is doing colemake based on this. So this mode 2, this is the thing that switches it to the arrow keys, and then this mode 4 right now is what pretends to be the mouse and switch it over. Dylan says, interesting, how long did it take you to make the switch? It took me a while to go from QWERTY to colemake, but it's worth it in my opinion. I did notice that I can type a lot more words using home row than I could with QWERTY, which is really neat. So I was watching a YouTube video about this yesterday or the day before, and that person basically said like, oh, you want to do Pierre, I'll show my code in just a second. I'll show you what I'm doing. I'm thinking about it a lot. Yeah, the video I was watching basically said, if you want more ergonomic keyboards, just don't use QWERTY. Like, pick whatever you want and do QWERTY. So I picked colemake. At the time when I switched, I was on Mac, and Mac has native support for colemake, which is nice. So that's kind of what got me switching to colemake. There's a version of colemake that is colemake DH, which has a couple other switches. So colemake I picked because Mac already had support for it, but it's also been designed more recently. So it's designed for people coming from QWERTY. So there's only like 1 or 2 letters where the letter is on the other hand. Which is kind of like one thing that makes it easier. It's easier to have things on the same hand. But then, yeah, it's pretty cool. I just got these keycaps, so I don't know. Maybe let me show you just. So split keyboards are the way to go, in my opinion, because you can have them wider out. Let me just show you so these are actually clear. I don't have the right NeoPixels for these, but I'm going to be soldering NeoPixels. They're browns. You can kind of see the brown through the clear keycap. And then there's a knob here that I don't have working yet, but I want to make it scroll because I like sit back and I like to like browse and read stuff, and I don't want to have all like my hands on the keyboard the whole time. So so I switched from, I am definitely a keyboard person. I should have warned you. So what I had before was it's got a bunch of cat hair on it. But this is the keyboard I had, half of the keyboard I had before. This is the Keyboard.io Model 1. And I liked it a lot. I think it was my first split. It's got like custom keys, and don't look too closely. There's a lot of cat hair in here. The reason I want to switch away from it is, one, I can't program this directly in CircuitPython because it's an 8-bit micro. And the other reason I think I want to move away from this is that I can't place it at the edge of my desk. So this is like the edge of my desk, and you can see that even at the edge of my desk, my hand's like a whole hand width in. And because it is, because I have cats, I don't often sit with my legs under my desk. And so it means that like I need to get my keyboard like closest to me, I have to really have it at the edge of my desk. Anyway, so yeah, and folks are pointing out that, yeah, Deshipu says QMK supports RP2040 now as well. You can probably replace that Pro Micro with the Adafruit board. So these are KB2040s on this. So they're already running RP2040s. But I kind of see them as kind of giant software projects. And I mean, I'm hugely biased, right? Like, I'm a CircuitPython person. And keyboards are not that complicated. So I'll just show you. All right, we talked about USB host stuff. We're talking keyboards. Patrick asked for an update on the broadband advocacy stuff, so we'll go over that too, which is not Adafruit related, but that's okay. An S3 that's a drop-in replacement for a Pro Micro. Yeah, these are older versions. I don't have the pink ones. I just saw that, though. They have pink ones now. So I don't have the rotary encoders working. I did add the UART. So PIO UART is transmitting from the right side to the left side because these are the SOFL designs, and they don't flip. You can't see me. They don't flip the wires, so you have to be able to use you have to be able to basically software do UART or PIO UART. I'm totally thinking that too. I'm getting into this recently as I'm having tennis elbow. Yeah, I kind of like constantly have issues. And I think that's part of the reason that I like switching from keyboard to keyboard is that like not doing the same thing over and over again helps. But one thing, I've been using this week. I was using this other keyboard before, and it's got those hand rests, and I find I lean on them a lot too. So another forcing function for these is that there's no place to put my palms of my hands, and so I'm forced to float my hands over. And I think my hands have actually been quite happy this week. I've not been hitting the right keys all the time, but generally my hands have been pretty happy with me. So I'm really liking this. I just got these clear keycaps. I had other DSA keycaps, which I don't have within arm's reach of me. But I'm actually really happy with this profile instead. If you don't know what I'm talking about, Like Fox says, I wonder what I joined it on. Looks kind of cool. We're talking keyboards. There's this thing called Pimp My Keyboard. They're actually in Washington State here. And this is where you can get all sorts of keycaps that you want. Adafruit carries keycaps, some keycaps as well, but these are the go-to folks, I think. Yeah, deep keys. These are this DCS clear set is what I have here. I didn't realize the thing that I got didn't have homing bumps, so I actually ordered them I did another order, and they're coming today because a lot of the trouble I've actually been having typing this week is just not having my hands in the right position. Like I've been shifted a row and then I type and I get all the wrong letters. So these keys, the like index finger and the pinkies can have bumps on them so you can tell that you're in the right spot. And those keys are being delivered today, which I'm very excited about. What I was going to show on here, though, is that they've got guides. Yeah, it's nice. I ordered those key bumps via USPS like yesterday or the day before, and they're close, so they're coming. They're out for delivery. Keycap family specs. This is a kind of a good way to see it. It kind of shows you the profile. Clear orange keycaps. I haven't seen any clear orange. The only clears I saw were these. Although in the comments for these, somebody talked about dyeing these to have like a tint. So maybe you could make clear orange. Anyway, so these are kind of standard keycap profiles. So DSA is what I was using, and they were kind of like little light, kind of tinsy. And I got DCS, which is like more typical, and they feel a little chunkier. They're a little clickier, and I'm liking them a lot. They've also got, I keep talking like you can see me. They also, the keys have a little bit of like a curve to them to kind of keep your finger kind of in line. One thing that folks new to keyboards don't always kind of blows their mind too is that these are ortholinear is the term. So all of the keys in a particular row are like lined up, whereas on a classic keyboard, they're not actually lined up. They're staggered. But ortholinear is the idea that your finger just moves like in one direction. So yeah, I've learned that I like DCS over DSA, and SAs are just kind of gigantic. I've got some of those too. And then low profile is kind of a thing that people like too. I do wonder about DSS, but I didn't really want low profile. I'm pretty happy with this now. So that's all about my keyboard. Let me just do a quick, because Pierre's maybe still on here. So it's all CircuitPython. Let me unplug. I've got lots of CircuitPython devices here. Oh, so I have my keyboard set up that it's only a keyboard, or it's only an HID device by default. But what I can do is I can hit reset and hold a key, and boot.py reads to see if a key is down. And if a key is down, and then it'll allow me to do CircuitPy, which is quite handy. So what you can see here is that I've got this, the JSON file, which is exported from that configuration thing. And then I'll show you my code. It's like 150 lines of code. And I've been thinking a lot about how I think this should be structured. One thing that is a major gripe of mine is when I see libraries that just have you call run at the bottom. It's like kind of like not, I like to kind of expose the loop part because I think it makes it clearer what's going on. Let me know if you want to see my hands. I don't type enough to suffer from any hand, arm, elbow issues. You've got plenty of years ahead of you to get to that point. Okay, so a bunch of imports. I've abstracted away some of the aspects of the keyboard into this SOFL module. I don't know how to say it. Standard USB HID stuff for CircuitPython. I create a keyboard and I create a mouse because I'm sending mouse keys. I release all the keys in case some were pressed down, which is kind of the worst failure mode. I'm loading the JSON in. I say I loaded it. And then this UART stuff is like whether I'm receiving or sending key codes. I have to do a little fanciness because the numbering in the layout doesn't quite match the scan matrix, which is unfortunate. But that's what this is doing. So this is going from kind of key number in the matrix into the index in the layout. This is the line. I'm using a stemma Qt connector, but I'm not using it for I2C. Expose the loop. Sounds like an awesome book title. Nice. Yeah, I mean, I like trying to design APIs where you can write what you want in like 20 lines so that you can see the loop and all of the things it's doing in the loop. I haven't gotten there yet with this code, but I'm thinking about it. So this is the mouse checker. So the first stage here that I want to factor out is there's kind of three ways that I'm going to generate a key event. One is I check the value of that mouse line. It's just like high or low. That's for the touch sensor on my left hand. If that's the same, then we check for a key event, which we get from, which actually this is a bug. we shouldn't do this because we won't handle it otherwise. Yeah, that's bad. Like, we should say else. See, if we do key event and the mouse thing's a problem. That might explain why I've been having some problems with it. Okay. So that looks more right. So this is a hugely risky thing. Editing your keyboard code from your keyboard is a bad idea, but I do have backups of this code. Because if you make a mistake, then your keyboard stops working, which is why I have an Apple keyboard on the floor here to rescue me. But maybe I won't save this. So there's kind of 3 ways we can get events. The third way is to get events from the other side via the uart. And then once we have the event, we're saying, oh, if we didn't actually get an event, we're done. We go through the loop again. But then we map the key number to a layout index, and then we look in the JSON file for the current layer that we're on and get the QMK code. And then we do this layer search. So if we're on a layer and it's marked as transparent, then we kind of go down the list. Save it. What's the worst thing that could happen? Yeah. Deshipu says, stopping working is not the worst that happens. It can get stuck with some keys pressed permanently. True, especially if you're hitting Control S. Which is how I usually save. Yeah, been there. Okay. So this is doing like the layer search, and then if the QMK code starts with MO, then we're switching to a different layer. If it starts with KC button, then we're doing a mouse button. If we're doing WH, it's a wheel. Otherwise, what we're doing is QMK code to a key code, and then we press or release it. And so that's all in 128 lines plus 1 custom module. So pretty clear, pretty straightforward, and very much heavily relying on the JSON mapping file, which has been really nice because I can then edit it. There's another standard called via, and vile is the open source version, and it's pretty handy to do that as well. Alma says, I have a question. Is Adafruit going to make a DIY VR controller, as they have made a VR headset? And I have it, but I'm using terrible controllers, and I was wondering if you would make some. We've not made a VR headset that I know of. I don't know. I don't think we'll do any guides with I don't know how you would hook those up. So Alma, my answer would be probably not. But you might be able to find ways of making your own controller if you want to use something else. But I think if your controller is trying to figure out where you are in 3D space, it's like pretty hard. It's not easy. Not an easy thing to do. Yeah, Pierre says, I love how you load the JSON from the QMK edit. Yeah, that's like... That was one of my requirements, is like being able to tweak it is really handy. Oh, Deshipu points out there might have been something like Google Cardboard in the Adafruit store at some point, maybe. Yeah, perhaps. We're not doing anything with VR right now, I'll tell you that much. Okay, so that's my keyboard firmware. It's not currently in a repo, so if you do want a copy of this, just let me know and I'll send it to you. Eva is doing a split keyboard guide and might actually use it. We'll see. But one thing that I've been thinking a lot about, and this goes back to USB host as well, is kind of coming up, really defining in my mind those stages. So you go from like the key matrix press into I think really what you want to do is you want to map that to kind of standard key codes, which is like the default mapping for QWERTY. And then I think what you do there is from the QWERTY mapping, you go to the custom mapping. So that's the phase that I would do like colemake. And then there's also kind of like a phase where you're determining what layer you're on. So I think, and then like, depending on what layer you're on, you do different mappings as well. Pierre, you can have this code, it's fine. I don't think it's all that much stuff. But yeah, just ping me on Discord and I'm happy to send it to you. I haven't put it in a repo. But so I'm thinking about the primitives that we have to map from like key codes all the way to USB presses. But then I'm also thinking about USB host, where USB host is going to give you key presses in like USB key presses, but you may want to transform it again. Another transformation that you may want to do is actually key code to serial. So like if you're in CircuitPython terminal, you may want to like change a backspace key press to the actual thing that deletes the last character. So there's another like transformation layer there from USB key code to serial input as well. So I think it's kind of like this whole stage thing. And KMK and KMK have these things, and you just say like do these in stage, and they kind of hide how they go from one to another. But I would like to try to come up with like primitives where you're actually doing it in the loop at the top level, so that the nice thing about that is you can see that it's doing a loop, and you can see the different stages of it, and theoretically print out what is the state between any part of that loop, if that makes sense. So you can see the process of how it goes from key codes all the way to USB or even serial input. And then I've also, the other factor of that is like, if we do USB host, then we want to be able to ingest that straight into CircuitPython. So that's kind of the transformation of like, how do I get from key codes all the way into serial input into CircuitPython? So that's pretty wild. I can make a repo for it after the stream. I do have really old, this is not the first time I've written keyboard code. Like I made a keyboard 5 years ago with CircuitPython and did the key scanning from Python as well. Like that's up in my repos, in a repo somewhere as well. If anybody has an idea for what to name this, let me know. It could be like Scott's keyboard. On macOS, you can screenshot the code editor in the stream and then copy and paste the code. That's pretty neat. Okay, so we're kind of at time. If folks have questions, let me know. I think Patrick asked for a broadband update, so let's just wander away from Adafruit stuff for a little while. I know folks kind of tend to trickle off after 4 o'clock as well. So if you have questions, I'm happy to answer them. But let me just go a little over the broadband stuff that's going on. So I've been trying to figure out the best way to advocate for more broadband access here in Washington State in particular. If you don't know, in the US, we have a lot of money that the federal government has allocated for broadband, so that kind of expecting about $1 billion per state. It's going to fluctuate a little bit, but in the next few years, we're going to get a lot of money towards broadband deployment. And people are always very careful to make sure that the rules don't say it's just fiber, but it should just be fiber in my mind. Cat KB, maybe. So the main thing that I've been doing is actually the site called Walla. I think I showed an older version of this that was like a GitLab instance. But a lot of the interesting stuff that I've been doing in the last month or two has been around this current legislative session here in Washington State, and tracking all of the related broadband bills. So I have this site here, and I think I showed this before at some point, But what you can do is you can click in. So bills are done by biennium, which is 2 years at a time. So we're in the second year of our biennium. So it's a short session, which means it's 60 days. We've got like 4 weeks left or something. So just to see like where all of the bills are, you can click into this page and you can see that here's in the Senate for the second reading. And I'm pulling data from when public hearings happen, people sign in pro, con, or other. And so what I've done is I pulled all of the data about whether people are signing in pro or con or other on a per bill basis. Have a good weekend, Pierre. So this is a kind of a cool way to see what the hot topics of the legislative session are. And I'm also pulling in calendar information so you can see when public hearings are happening or executive sessions. So that's kind of neat. And then more broadband specifically, we can do... So one thing we're doing is there's a change to the definition of broadband, which I thought they revised it. But it's changing the minimum from 25.3 to 100 down, 20 up, which is generally a good thing. The words here were a little bit tweaked, but I think generally we're for it. So that means that state subsidies can go to more places, which is good. And then there's also a right to repair bill is the other one that we've been following, which is this electronics repair. You could see a lot of people signed in pro, only a few con, and those tend to be lobbyists. So those are big thumbs downs that impact stuff a lot. And you can see it's been substituted, but this is a cool thing too, and it is making progress still, which is good. So that's kind of where I'm at on the broadband stuff. I haven't been working on this. I'm keeping it up to date, so I run an update thing every night. You can see it's all hosted on GitHub. So it's just wala.org, tna.com/wala. We is the royal we, or is their group? Maybe something we can donate to. So I'm on a Slack for a group called Share the Cities, which does kind of activism stuff, housing related stuff, but also broadband right to repair stuff as well. So I'm kind of like plugged in via that group, but this site has almost been me, but there's one other person that's done a few PRs as well, for night mode and titles and stuff. So James Wu here has contributed a couple stuff as well, which is neat. But yeah, thank you GitHub for doing free hosting, because there's like 15,000 files in this repo. It's not small. But yeah, that's a quick update on where I'm on the non-Adafruit side of things. Will there be a way for us to see updates after this spring? What do you mean? Like the laws aren't going to change if there's no, the laws aren't really going to change if there's no current session. The next session, unless the governor calls a new session, it won't be till next spring. Next January is the next session, the next regular session. But it's still going on. Lots is happening. But yeah, if you want to know more, I'm happy to talk more, but I think we should wrap this up because I know folks are leaving. And I can connect you into this group that they're looking at too. But right to repair is one of the more interesting tech sides of this. Mostly once you've got parental responsibilities, where they'll be always keep following along on what, like the law stuff. I'll plan on just auto update. I'll manually updating it through the end of the session, and then I probably could do a GitHub Actions to automatically update it, but I don't know if it's worth it. I have analytics on it, and not a lot of people are looking at it. So, all right, let me pull up my notes and wrap us up. Oh, you know what? I think my notes are here. It needs marketing to get the word out. I actually got mentioned in The Stranger a few weeks, so I have nice spikes when The Stranger mentioned it. But it's kind of, after those spikes, it's kind of dropped down to the normal level. And people are still sharing the normal, or the direct links to the legislative website. Oh, Dylan, yeah. Internet upload speed is sad. 100%. So yeah, I know a lot about broadband in Washington State, so please let me know if you're interested in that. A lot of what I've been trying to do with this voila thing is just figure out if there's something that really catches people and like gives them the motivation to actually come back, which I don't think we've actually found yet. But people were interested about the thumbs up and down stuff. Okay, camera. Thank you all for joining me for yet another deep dive. Thanks for hanging in there towards the end through this Washington State specific stuff. Yeah, keep an eye out for USB host. I'm around the next few weeks. I am planning on kind of like stopping streaming before the baby comes in the next few weeks. So we're limited time left. But Foamy Guy's going to take the spot, and so somebody will be streaming on Adafruit around this time. As always, I'm sponsored by Adafruit to work on CircuitPython, so you can support them by going to adafruit.com and purchasing some of the stuff you saw here. If you want to chat with me and a lot of others outside of the space of a stream, like you're watching this after the fact and somehow you watched all of it, and you want to come chat with us, you can find us on Discord by going to the URL adafru.it/discord. Me and a lot of other great folks are there as well. Deep dives happen every week, at least with me for the next few weeks. Normally it's at Fridays at 2 p.m. Next week will be Friday as well. And typically goes for about 2 hours. This is actually a little bit long. All notes are available on GitHub. Thank you to Patrick and David for taking them, Patrick for curating them. They're available on GitHub, github.com/adafruit/deep-dive-notes. And they have time codes there. So if you ever want to find, like, when did Scott talk about this one thing, that's a great way to find it and then jump into the video where I actually talk about it. So thanks to folks for that. And I'll take my mic off and pet the kitty, as I always do at the end. And after the stream, I'll try to get this Python keyboard code just dumped into a repo for folks to look at. And then next week, I'll be trying to really dig into USB host and see how far I can get with getting PIO USB host in TinyUSB next week. So I'll be around next week for an update on that. And then maybe a week or two after that. I haven't worked out with Foamy Guy exactly when we're going to swap over, but soon. Time is going by fast. It's like almost the middle of February already, which is wild. Anyway, I'll get over to this kitty, and we can chat more in the Discord about the broadband stuff too, if you're interested. All right. Would you like pets? Your kitty potted up. Not in your bed. You gonna get up? Oh yeah. Oh yeah. Kitty, kitty. He's been loving the sun today. Thank you all. Have a great weekend.